Now we're going to begin looking at arithmetic sequences. Arithmetic sequences are sequences in which a common difference exists between terms. For example, we have this sequence here which begins with 2. 2 is our first term, a sub 1, and we are adding 2 to go from term to term to term, so d is equal to 2. Now we could say that 200 is our nth term. We could also say, because we know we're adding 2, that this is the 100th term. Okay? Now let's generate a formula for the nth term. Notice to get to the third term, we started with 2 and we went forward our difference of 2 twice. We went forward twice to get to our third term. To get to our fourth term, 8, we'd start at the 2 and we'd move forward our difference 3 times. To get to the 200, which is the 100th term, we'd have to move forward 2 99 times from our starting point here. Basically, this helps us generate a formula. We say that the nth term is a sub 1 plus n minus 1 d. In other words, have a starting point, a1. You're going to add on the difference n minus 1 times to get to the nth term. Now let's get some practice dealing with arithmetic sequences. Let's first off determine whether this is arithmetic. To go from 8 to 0, we are subtracting 8. So d appears to be negative 8. If we add negative 8 to 0, we do get to negative 8. And then if we add negative 8 again, we do get to negative 16. So yes, this is an arithmetic sequence. Now let's look at the next one. Yes, it appears we're adding 2 to go from 2 to 4, but adding 2 to go from 4 to 8? No, we're adding 4 and then 8. So no, we do not have a difference of 2. This is not arithmetic. Now they want us to find the first 5 terms of the sequence based upon the information they give us. We are basically being told when d is equal to 5 to add 5 to go from term to term to term. So our first term is 6. We add 5 to get 11. Add 5 again to get 16, add 5 again to get 21, and then add 5 again to get to 26. So that is the first 5 terms of this arithmetic sequence. In this sequence, we are being told the first term is 7. We are being told that the difference is 9, so we can add 9 to get to 16, add 9 to get to 25, add 9 to get to 36, etc. But we need to find the 48th term, and that's impractical for us to write out 48 terms to get there. So we're going to use the formula that allows us to find the nth term, which we generated earlier and which you need to memorize. You begin with the first term, and then you add on the difference n minus 1 times. So in this case, we want to find a sub 48, which means start with 7 and then add on this difference of 9, 48 minus 1 times. So this will be 7 plus 47 times 9, which is 7 plus 423. And we can find that the 48th term of this sequence is going to be 430. Now this time we're asked to find the 46th term, and we're given the first term and the 60th term, but we're not told how far apart the terms are. So again, we're going to use this nth term formula, a sub n equals a1 plus n minus 1d. And we're going to use what we have here. We're going to let the nth term be the 60th term. So negative 262 will be 210 plus, now that was the 60th term, so we're moving 60 minus 1, or 59 terms forward, some value d. When you subtract off the 210 on each side, we now have negative 472 is equal to 59d, and dividing by 59 on each side, we find out that d is equal to negative 8. We're adding negative 8 to go from term to term to term. Now that we have a value for d, we can actually use our nth term formula again. I'm going to redraw this again, and we're going to say the nth term is the first term plus n minus 1 of these differences, and we want to find the 46th term. So we will begin with 210 and add on 46 minus 1 of these negative 8s. This turns out to give us negative 150 for the 46th term.